So we're going to look at exponential functions. We've done a fair bit of work on these, but just to remind us after we get to the end, so it's a good point in time to reflect on what we've learned. So I'll put the general form of our sketching. This is specifically around sketching. The general form of our exponential there. You can tell it's for sketching because it's in form HK. So what do each of these variables do to our function? What does the A do? Thanks. Brad. Yep, and if it's negative, what does it do? Not reverse. Reflected around what axis? The x-axis. Very good. B, what does B do? Thanks. Sophie? Which type? Yep, horizontal, and we'll flip it around the y-axis. Yes. I'm not going to write that, you just need to think about what's actually going on. You know what a negative does, just think about what's going on. H, what does our H do? Horizontal translation. And our K, Kara, does what? Yep. What does the K value? It's got a special name. What is it? Yep. I haven't drawn the general form of the log, but we can probably put that in. You can probably figure it out on there. All the values do the same thing. The only difference is for our log functions we see a vertical asymptote, not a horizontal. Yep. Yeah, it's spot on, you pass the spelling test. So if I've got e to the power of fx, what does the derivative of that equal? Oh sorry, e to the power of gx, what's the derivative of that? G dash x. And what do we have to be careful of when we're doing our formula sheet? What's on the formula sheet? Yeah. I've got something like this. That doesn't help us for 99% of the functions. Okay, so it's almost always, think about chain rule as the derivative of the thing. So we can, if we're in doubt, we can use chain rule, but we know if you've used chain rule a few times, it's the derivative of the u, which in this case is the power. An example here, what would that become? Should take 2 seconds to do that. What's that say? 2, so what do we say? 2. Okay, do you think it's 7? It's 7x, e to the power of 6. If you think it's a 7, that should not become a 6. The power stays exactly the same. So that's a very common misconception. A lot of the times when kids are deriving these, they take one off the power.
If you see it brought down, 7x.
That would be 7x to the power of 6, sorry. Yes, that would be. Sorry. Now that is actually a 2, which would make that 2x e to the x squared. That's what it should be, but my handwriting is not very good there.
Oh, is it?
That's what it's supposed to be. Thanks, Karen. Therefore, we identify here what's e to the kx become if we're integrating it. E to the kx over k plus c. You forgot plus c into the plus c jar. To determine exponential equations, so one of the things that we were asked to do in that, in the later half of the chapter 1 review, was to create an expression to deal with models exponential decay often, but it can be exponential growth, but often exponential decay. Now to do that, we need to have as many points as we have variables. So I'll say that again. To do that, we need to have as many points as we have variables. So if I've got in this form here, how many variables do I have? 3. If there's no d value, how many variables do I have? So how many points would I need if I've got a d value? How many points would I need if I've got a no d value? 2. What's often an easy value? If I have, what should I do first? If I've got a time is equal to what? What do you think makes solving exponentials easier? When time is equal to? 0. Correct. Write those down. work with you? Yes, we'll do. Okay. Yeah, we'll do. We'll work. Okay. So that's the first thing. Obviously, when we're solving that, we then need to use our log laws. And one of the things with our log laws is knowing which log to use based on the base. So more often than not, we're dealing with base e, which would mean we should use log what? Log base e, which is ln. Sometimes we'll get the one in the second column there where we've got b, and you can use your log base 10 or your log base e. It doesn't really matter. So for exponential functions, they have an at their k value asymptote. So the general form will look something like this, where our asymptote is on the x-axis. That's assuming there's no vertical no vertical translation. A log function has a vertical. I don't know what it's called, but I'm going to call it asymptote again. I don't know if that's exactly what it's called, but anyway, it looks like that, where it can't cross that value there. Why does that happen? Logs cannot be 0 or less. They must be positive, greater than 0. Cool? Happy with that? And the reason why we've got our asymptote there, it's the whole walk towards the door, half the distance, half the distance, half the distance, you never actually reach the door. Sweet. Okay, log laws. Log A1 equals?
0.
Log AA equals? Log AN plus log AM equals? Log A, what is that? Yeah, log AN minus log AM. Okay. And the last one? What do I call that law? I call that the log law, because you can plonk the power of the pair at the front. Cool? Happy with that? That is something that comes up a lot in your externals. Often they'll give you something like half log e to the power of 4. And you'll think, look, I've done my final solution, but I'm not. What do I have to do? Take that up, so it becomes log e 4 to the power of a half. What's 4 to the power of a half? Yep. So just being aware of that law and where it applies. Cool? Oh, one of the things I haven't mentioned here is this. I just put a little note on it here. Half-life problems are something we haven't seen for a while. One of the things that you need to know about your half-life problems are that if you have a half-life, so it'll say the half-life is equal to 10 days or whatever, you actually have a bit of information there. So they won't often give you numbers. You're looking for numbers to sub in, and they'll say the half-life is equal to 10. Well, you know that when time equals 10, n equals NO on 2. What's going to happen to the NOs? Grace, what's going to happen to the NOs? You don't know? Maybe looking up rather than looking down is probably the way to go. If n equals NO on 2, and you're isolating the variable k, what's going to happen when you divide both sides by NO? They're going to cancel out, so you've essentially got rid of a variable there. Sweet. Just be aware of that. Index laws. What's that equal? Thanks, Max.
A to the B.
Is that what you said? A plus B? Yep, good. I thought that's what you said.
Yeah.
100.
A on B. A minus B.
So his name's Nick now.
It is now.
Cleaning version.
1.
What's that backstep from which?
0.
It's back from which? C? Okay, what about this one? What about this one, Brad, from which? No, you're Brad. Brad from which? No, you're backstep from which? Brad from which? Brad from Wish, what's this one?
Yeah, I'll just do the hardest one.
Yeah.
I can do it.
Okay, thanks, Patrick.
E,
Yeah.
top, M on, N.
Yeah, and
M on?
and it's a-
On, N.
Yep, so the power that goes to the denominator. Cool? Happy with that?
Let's go.
So that's a summary of what you should have done in the chapter 1 review. If you have done all of these questions, I'm going to set some more in a second, but obviously you need to make sure you've done all of those. There is no point pushing on telling yourself you're all good when you are not.
So,